record to this computer. Okay. All right, so I think we're recording. Do we have a screen share? Yes, we do. Perfect. So we are doing the logistic regression, and for it, we're gonna be trying to predict the responses, and that means these guys.
Right.
Now I converted them into, or you did, convert them into ones and zeros. That's always good. Because the analysis prefers numbers over anything else. But I guess I haven't tried it, but I think it works both with the letter Y and N, as long as there's two values and no other.
Yeah. And the class we took last semester, it was like you have to convert it into ones and zeros.
Yeah, yeah. So anyway, we're gonna try to predict this variable rest num. And I'm just gonna write that down. Rest num is going to be predicted by, well, now is the question, by what? Well, we know that we're gonna try to use pi, the pi ratio, and what else do we have? We have shape. And if the pi ratio is the relevant invariant information, then shape should not matter. So we can throw it in as a variable and express it like pi times shape.
What about like diameter and curvature?
Excuse me?
So what about like diameter and curvature?
Well, that's the diameter is already included in the pi. So we're not gonna use it again, because that's like using it twice.
Okay.
And then the shape is in the regular pi, the shape is not included per se. It's going to be included in the adjusted pi, where it's the curvature that we use. Okay. So shape is going to be used. And we don't have size manipulation here, do we?
You mean like what?
Yeah, we do actually.
Yeah.
So size goes from 1, 2, 3, 4, 5, 6, 7, 9. Okay.
Because there are 9 sizes.
Yeah, yeah. I'm just wondering if we need to label them with words to make it easier. But I guess 1 is the smallest, 9 is the biggest. Okay. All right, that's fine. So we could try to use both of those, shape and size, with the pi, and see what we get. But then we could also then use the adjusted pi, and with the adjusted pi, shape should not matter, but we can check that by still running the adjusted pi by shape interaction as a predictor in the logistic regression, with the expectation that it shouldn't matter. Okay. So I'm just gonna bring in the old analysis from the thesis to show you how actually what the output should be. So let me just do that real quick. With the plots, that's what we're going for, and then we're gonna try to create those plots. Right here. So let's see if we can see those plots. Here they are. Okay, so see how I have several different types of visualization here. This one is where we predict perceptual responses with pi and shape.
Okay.
But we are getting what, 1, 2, 3, 4, 5 different curves, and that's not a good thing because it's a one-to-many mapping, and we're looking for one-to-one mapping between the informational variable and perception. So shape is not collapsed over. It's not collapsing over the function. We have 5 functions, and that's not good. So instead, what I've used is the adjusted pi that accounts for the curvature instead of the diameter, plus shape, and now shape is there, but it's basically the same function. So this demonstrates that shape doesn't matter, and that whatever perception is based off of is invariant across different shapes. And that particular informational variable might be the adjusted pi, that is the ratio between curvature and handspan. So that's what we want to demonstrate with um with with the grabber experiment as well. So that's what we're going to try to do. Okay. All right. So I'm going to close this for now and get back to us. So that's what we want to recreate. But we need to have what's called predicted probabilities. I'm just creating a new column as a placeholder for the different versions of the regression analysis. So I'm going to use this with pi, and I'm going to make it interact with what did we say, shape. That's going to be 1, and then the other predicted probability is going to be with,
I adjusted.
that's what we call it. Okay, so pi adjusted by shape. Okay.
Other side.
Okay. All righty. So what we need to do is load this into SPSS. Okay, so there's several ways that we can do this. I'm going to do it sort of hopefully in one fell swoop, because I don't want to type all these names in for the variables.
Right.
So what I'll do is I'll create a new sheet where there's just one sheet for the Excel. Copy this sheet. Oh, I didn't copy it right. Sorry. I want to copy it with the values only. Now it's gonna cancel all the, when I do this, when I copy it just for the values, I'm destroying the formulas. So now the formulas are no longer there, but the calculations remain. If you do it other ways, it won't transfer. It's a little bit difficult. So we lost the calculation, but it's not going to survive the transfer to SPSS anyway, so it doesn't matter. Yeah, I'm just going to delete these. So I'm going to save it as something. This is just going to be a temporary file for us. And so I'm just going to put it on the desktop. It doesn't really matter. Okay, so that's what we're going to take, because it has all the 4 subjects in it, which is good. Close it. And then I'm going to open SPSS. And now try to import data. So in File, I go to Import Excel. And I'm going to look for it on the desktop. Oops. Where's my desktop? Oh, boy,
You have to go back and each one.
yeah. There we go. Let's stop and SPSS. Hopefully, it's just gonna import everything with
Mhm.
the headers preserved, because I didn't want to type it all in. Let's try it. Okay, it worked. Perfect.
Oh, that's a lot of decimal places.
And we can change that. So in the variable view, we can change that. See, these things can go down. So I can just use maybe 4, not 415, 4. Just like so, and then it will be manageable. Okay. Now, one thing that I forgot is that obviously this experiment is about the comparison of hand versus grabber. And here also, what we're trying to do is demonstrate that if we find the invariant that specifies exception, then it really should not matter whether we're looking at the hand or grabber. Excuse me. So again, the curve, the two curves, the curves for the hand and for the grabber should collapse onto one curve if we are using the right variable.
Okay.
So again, maybe that's an additional factor
So-
that we have to add.
By shape, by tool.
Yeah. Yeah,
Okay.
and see what we get. Okay, so we have everything that we need. And now we have to keep track of what we're doing, because we're going to do several different versions of the regression.
Okay.
So
Might need a piece of paper.
yeah, I might need this paper. So let's do that. So first, because it's going to be slightly different than what we did for Mackenzie's thesis, because she didn't have the tool as a variable. So we're going to do obviously pi. So perception is going to be a function of pi and shape and tool. But we're going to do maybe do it in steps to see whether that matters.
Okay.
So let's try it. I'm going to go to analyze, and I'm going to go to regression, and then I'm going to go to binary logistic. Now, the dependent variable is the thing that we want to predict is the response numerical. So we're going to put that in. And the predictors in SPSS are called covariates. Another difference between the labels that we use and what SPSS uses.
Yeah, the main thing I've taken away from the 2 stats classes is everything has 3 different names.
Yes. So then the first thing that we're going to select is pi. So we're going to put that in, just like so. And then we're going to keep adding stuff. Let's just try to run with just pi and see what we get. Just with that, and then
Why did that twice?
no, I don't think so. So we pi and adjusted pi.
I don't want to wait when you put it in the.
No, it doesn't go away. So
But response number isn't an option anymore when you put it in a dependent variable.
that's true. But we have pi here. Let me see if we can find it. No, it's just there. Maybe it's a different kind of mechanism for covariates. And let me just check something. Enter. I'm just gonna check a couple of things. I don't want to make it categorical, which would, again, we talked about this before, like, is this a categorical variable or continuous variable? I'm gonna keep it continuous because it really doesn't have categories, neat categories. People have different sized hands. The pi varies between, I guess, essentially between 0, even though it never goes to 0, and whatever. But it's a continuous variable. All right, so what do I want to save? I want to save the predicted probability values. I want to check that. That's important. Everything else is not important for our purposes here. Let me look around some more. We don't need any of this stuff. So we can just click through it. Bootstrapping. We don't need any of that stuff either. Style, nope, nothing there. Okay, so let's just try to do it. Click OK. And what we are going to do is the first thing that we're going to do is model summary. Model summary just basically tells us how good is this fit. How good is the fit between a pi as a predictor and perception as a outcome variable. And in order to assess that, we look at R squared. It's a special kind of R square. It's called Nagle-Kerke R square that explains, that tells us how much variance is being explained. So in this case, it's 0.238, which means roughly about 24% of total variance is explained by pi.
Okay.
In some quarters of psychological research, that's big.
Mhm.
So that's decent actually.
But here we want it to explain basically everything,
You're never gonna be able to explain
Right.
everything. So
but as close to everything as we can get.
yes, but it's not gonna be like 0.9.
Okay.
So that's there's so much variability in the data that it's not gonna happen.
Mhm.
Okay. Then this other thing that we're gonna have to look at is the coefficients of the regression. So pi comes with a coefficient. It's minus 3.2. So it's a negative coefficient, which means the higher the pi value, the more likely are you to start saying no, which means responding with 0. So it's an inverse relationship,
Okay.
numerically speaking.
Mhm.
You know what I mean? So that's why it makes sense to put in numbers, zeros and ones, because then it's easy for us to interpret the negative value. Because
Mhm.
if we remain with letters, then it actually goes by alphabetic order, and it's just a luck of the draw or a language that you use for
Right.
saying yes or saying no.
Okay.
Which one is going second and which one goes first. So 1 is always 1, higher than 0. And it makes sense, right?
Mhm.
To have a negative B coefficient.
Yeah, the closer that pi gets to 1, the bigger the object is in comparison to your handstand, the more likely you are to not say, no, I won't be able
Yes.
to pick it up.
And so it turns out to be statistically significant because this is the p-value
Mhm.
for it. It's p less than 0.00.
Yeah.
Yeah. So it's very significant. That means that it's capturing significant portions of the variance.
Mhm.
Okay. So now one other thing that I want to go back to the actual data sheet in SPSS. You will notice that it created this additional column.
Oh,
These are the predicted probabilities. So it's trying to, in logistic regression, it's trying to estimate what should be the predicted probability for a given value of pi. So you have all the values of pi. For every associated value of pi, it's going to try to estimate what should be the predicted response
How likely to
that
say
is,
yes or no?
yeah, how likely are they to say yes or no for a given pi value.
Mhm.
And it's basically going to be the coordinates of that logistic curve that is the curve of best fit.
Mhm.
And that's what we're going to plot in Excel. But I'm not going to plot it just yet. I'm actually going to rename it so that we know what it is.
That'd
Because
probably be helpful.
we're gonna be creating a lot of these.
Mhm.
So this is predicted just pi. Okay. And I'm gonna do another one. But now I'm gonna enrich the model. So go to regression, binary logistic, and now we have pi in there, but I'm gonna add shape to it. Okay. I'm gonna add shape, just like so, and it automatically adds shape as a categorical variable.
Because it's words and not.
It's
numbers.
words, yeah, so it cannot, there's no other way for it to interpret it. You cannot have a continuous variable defined by words.
Mhm,
That's not possible.
mhm.
All right, so again, we're gonna see what it's saving, probabilities, good. And all the other options are remain the same, so I'm just gonna click OK. And now we run this more enriched. Now it's a multiple regression because it has more than two, more than one predictor.
Mhm.
So we're gonna again look for the R square. It's 0.257, a little bit higher,
26.
26%. It was 24%.
Mhm.
Now it's 26%.
So slightly more variance.
Slightly more variance. Importantly, we're gonna look at this particular output here.
Mhm.
The coefficient for pi is still negative, still highly significant. The coefficient for shape is going to be significant as well.
Mhm.
And this is where it gets a little bit confusing because it says shape parentheses 1.
Mhm.
So let's look at how we define shape. Did we define it with words?
Yeah,
Yes,
so it was a
cube and
categorical.
sphere. Okay, so I think it goes in alphabetical order, if I'm not mistaken. And then it's gonna be the comparison between sphere and cube in that order.
So as we go from, because it was a negative number, yeah.
It's gonna,
So as we
it's a
go from
negative number, yeah.
cube to sphere, they're more likely to say no.
But I think I have a way to check this. So let me go into the analysis window again and see if I can make sense of this. Because let's see, not this part,
When it's showing.
the categorical part. Okay, so if I highlight this, then I say, what is the reference category here? And it's gonna be the last category. So we have two categories, cube and sphere, but it's gonna put it in alphabetical order. So which one is the last one? Sphere.
Mhm.
So in fact, here in the shape 1, that stands for sphere because that's the last in the alphabet. Actually, no, I'm sorry. That's the reference category. So shape 1 is actually the cube. Okay. So the cube is compared to the sphere, and that makes sense for the minus. That's how we're gonna be able to interpret the minus or the plus of the coefficient.
For future analyses, would it be better to just go ahead and convert the shapes into numbers so that we can say definitively?
Yes, but then you also have to keep track of what the numbers mean. So in Mackenzie's study, we had 5 different shapes, and I had to actually keep track of shape 1 is a cube, shape 2 is that cuboid, and then shape 3 is the mid shape that is equally cube and equally sphere, and then shape 4 was a spheroid, and then shape 5 was a sphere.
Fortunately, we only have 2 shapes here.
Yeah, so
Easier
it's gonna be easy.
Keep in.
But in order to interpret the sign of the coefficient, you have to know which one is the reference category. So here is the last one, alphabetically speaking. So that will be the sphere. It might show up as, you know, which curve, the sphere curve or the cube curve is moved, shifted right or left in the plot.
Okay.
That's all there is, but it's going to be revealed to us if we plot it. Okay, so then I don't want to do this again because it's already done. Because guess what? If I redo the analysis, it's going to create another column, which it already did. So it
Right.
created another one
I
now
want to.
that I'm going to rename. I'm going to rename it pi times shape, just like so. Save it. Oh, it's not even saved. Good idea to save it. So let's find our little corner. I'm gonna say N4 to indicate how many subjects we have.
Okay.
Just so I remember what this was.
Mhm.
Okay, good. So we have this, we have that. Now let's add the tool as
Okay.
a third predictor. See if it actually significantly contributes more to explaining variance above and beyond everything else that is in there, pi and shape. Okay, so I'm gonna again, same thing, analyze regression, binary logistic. Pi and shape are already in there, so now I'm gonna add tool. Where's the tool? Here. And again, this is gonna make it categorical because it's words, right?
Mhm.
So we have, what do we call it? Hand versus
Grabber.
grabber. So I guess hand is gonna be the reference because that comes later in the alphabet.
Mhm. So it'll be as it goes from grabber to hand. Does the chance of saying yes go up or down?
Yeah, okay, so we just have to check that everything is there. Tool, again, you can change this if you want to. It doesn't really matter. Let me just check here. No, we just want simple indicator. Okay. All right, so let's do that. Out of all this, I'm again just looking for the model
27%.
summary, 27% now for the R squared. So we're inching up a little bit. So let's consider now the contribution of tool is negative, okay,
So
minus.
as it goes from grabber to hand, they're less likely to say yes.
Actually, as it goes from hand to grabber, because hand is the reference.
Okay. You said that sphere was the reference to tool.
The tool?
I mean, for shape.
Oh, but I'm talking about the tool now.
Right. But you said that if the sphere was the reference for shape, I thought we were still talking as it goes from cube to sphere.
No. Each variable has its own reference. So
So the
tool
reference-
has two values, right?
Yeah.
Hand and grabber.
So the reference one level, whatever you want to call it, that's the first one, and then it goes from the first one to the second one.
Mhm.
Okay.
So, but the effect here just tells us what as we go from the first from the reference category to the other
Not-
one,
Okay.
how does the
Okay.
perception change?
So it goes from hand to grabber, well, I was in it, which makes sense because the grabber is smaller.
All right, so it's significant, but it's kind of like weaker a little bit. It's 0.016, still significant, but or maybe not the strongest tool in the shed. Okay, sharpest tool in the shed. All right, so now I'm gonna rename this guy to be pi by shape by tool. And I'm gonna do one more. I'm gonna do one more for us here, where I'm gonna skip shape. And I'm just gonna do a pi by tool.
Okay, so we're not gonna do adjusted pi at all?
Yeah, we will.
Okay.
But for now, let's just try to plot this. This is plenty. Okay, so that's that. Let me go to analyze, regression, binary logistic. I'm gonna take out shape. And not even consider it for this one. Let's see. Nothing has to be changed, so click OK. Okay, so this one explains 25% of the variance. And it's still significant, so it really didn't change much. The coefficient didn't change much. Pi didn't change much, so we'll see. But I'm gonna rename it so that I know that this is pi by 2. You want to try the adjusted pi?
No, I'm good.
Now I'm curious, actually. Does it explain more variance?
I'm good with just watching you for the time being.
Okay. I'm gonna do it. You know what? Because I'm interested. And this is ultimately what we're after. So let's try to do it. Finally, logistic. I'm gonna take out pi. I have to take out all of them because they go in order. So adjusted pi is thrown in. And now I don't have to put in shape because curvature defines the shape implicitly. And I don't have to put in size, which was already accounted for the pi.
So tool.
So only 2. But in the first iteration, let's just use pi alone.
Okay.
And it's not categorical. Saving for predicted probabilities. Okay. 26%, 25.8. Okay. Highly significant. That's good.
So adjusted pi by itself explains slightly more of the variance than normal pi by itself, but it explains about as much variance as pi plus shape did, which makes sense since adjusted pi is inherently taking shape
That's a
into
good
account.
logic. That is a good logic. So what do we call it? Pi adjusted. And now let's try to do regression, binary logistic. And now we're gonna add tool. And tool is going to be, where's that? There. Selected. It's the last one. Okay. All right, so let's do that. 27%. And it's significant. Tool is significant.
Again, explains about as much as pi shape and tool altogether did.
Yeah.
Again,
yeah.
it makes sense.
Let's label it.
I think you forgot to do pi adjusted.
Uh-huh. Okay. All right, so now I think we have most of the things that we need. Now we're gonna, the way that we save the data, I'm gonna go back to our Excel sheet now. Order matters, right? So I imported this Excel sheet into SPSS with the trial order as it was.
Okay.
And I wanna just now take all of these and put them into the Excel sheet so that I can plot. But I want to check that the trial sequence is preserved. Yes, it is. I'm checking this so that it's not screwed up. Because the predicted probabilities are associated with a unique value of pi or adjusted pi, whatever, and the other variables. So everything has to line up. So I'm just gonna take these, copy, and stick them in here. Maybe the labels are gonna be messed up, but let's try. Yeah. So I'm just gonna do it this way. And I'm gonna have to relabel. Where we say pi shape tool. So this is actually pi. This is pi by shape. And then this one is gonna be pi by shape by tool. And then
adjusted pi. No, pi by 2
Yeah.
first.
Mhm.
Pi by 2 first.
Is it? Oh, yeah, because we did that extra one. Okay. Then what do? We have predicted probability of now pi adjusted, yes, alone or
Yeah, and then we did pi by 2. I mean, pi adjusted by 2.
there we go. Okay, so we have everything we need. Good. So now let me go back to again Mackenzie's plots to see how we actually have to sort the data, because that needs to be taken care of to have like a good plotting experience. I'm actually gonna take this and copy it over there.
Okay.
And the reason for it, well, she had five shapes. Now we're just gonna have 2 shapes. So it's gonna be simpler for us, but we're gonna have tools. So we're gonna have 2 shapes by 2 tools. So we're gonna end up with 4 curves, I think. 4 combinations of cube with a grabber, cube with the hand, and sphere with the hand, and sphere with the grabber.
All things.
Okay, so let me take this. I'm just copying. And then I'm gonna modify it. Okay, here we go. It's a little too big. All right, I'm gonna change the scale and all that stuff. So this one, we can start with the pi by shape, which would be pi by shape is this.
That's
No, it's 2. Pi by shape is that. So column P. And let's do the cube first. So that's where the sorting comes in for plotting, because I'm gonna have to select, right? So see here, the shape is cube and sphere. Now I'm gonna take all of these, and it's important to select all the columns to preserve the order again, and don't mess up. If you leave out one column, then that one's not gonna be sorted according to the others, and we're gonna lose the connection.
Right.
So we select all of them, and then go to data, sort, and sort by shape. Click OK. And I'm checking now. All these are cube across all the participants. Now we do have action in here, so we want to take that out. Oh, we didn't take it out. We made a mistake. That's okay. It's a minor mistake. Now we're just gonna predict everything together, perception and action together. That's okay. For this exercise, let's just do it all meshed in. I wonder why this has messed up. Let me check. Something got screwed up here.
Oh, since it's a formula, it might, let you,
Let me go back.
yeah. You,
and try to go back. I wonder what
messed it up?
messed it up. You know what I mean? Because we didn't really do anything.
When you copied it over to the other sheet, did it do it?
No, I cannot because it's it was there. And this was, yeah, I don't understand what happened there. Oh, well. Let's see. This is why I don't work directly with the file that you shared. This is one, see, because now you would have lost all of this work.
Well, I have a copy that I have
Copy,
on
copy,
my,
okay.
yeah, so I have
So-
the file that you just saved to my computer, and then also the one that's on OneDrive,
I wonder,
I think.
okay, let me go back because I did all this work to actually save all the predicted probabilities. They are in the right order, so we're gonna,
Well, you could copy and paste it to the sheet where you made a new, copy all by itself.
that's what I'm gonna do. Because it survived that. It's right there. It's just, we're not gonna be able to resurrect the formulas, because this one doesn't have the formulas anymore.
But we should need the formulas for what we're gonna be doing right now, right?
Doing right now, but since this is the master sheet, we would want to have the formulas.
Yes, but
Yeah, let's just do it now for the sake of the,
there should be a copy of it
Exercise.
somewhere that still has.
so diameter. Basically all these columns, and I wonder, okay, so, yeah, it's not gonna give us any grief. Because they're
Oh,
not
I
even
meant
formal.
copy and paste the PRE values into this document. So that way
Oh,
the formulas are preserved in
Okay.
that one, we just don't quite know why they're
Oh.
not working.
better, even better idea. Let's do that. Let me just check here. 1, 2, 3, 4, 5. Participant, okay. I'm gonna actually also close this. We can work with the other one.
Don't say anything.
Nope, I won't say. And then I'm gonna copy this one over here. And I'm gonna close this.
You might need to move it so that the Zoom screen can.
Yep, we're back in Zoom.
There we go.
Okay. All right, so we said we need to sort by shape. Okay, so cube is first. So I'm gonna go into this and clean it up a little bit. So the way that I do it is, oops, I wanna highlight one of the curves, right click, and then go select data. And then I'm gonna delete everything that we don't need. We don't need the spheroids. We don't need the mid. We don't need the cuboid. We just need the sphere and the cube. Okay. And let's try to work with the cube first. So edit. Now, this is gonna point to a different file, but that's okay. I'm gonna go back and select the X value should be the pi. So we're in the cube, and I'm gonna select starting here, going all the way down to the last cube row. wherever that is. There we go. And that's gonna be the pi. Then with the tab, I select the y values, so those are gonna be the predicted probabilities. Now, let's see if I didn't freeze the first row. So we're doing pi by shape. This is the column P. So I'm gonna select that. Click, hold, drag,
Mhm.
and release. It has to match up. So I should select just those rows and no other rows. I think I'm lined up.
Yeah, I think so.
Click OK. We're gonna do the same thing for the sphere. So pi is n. There we go. It starts right here.
That's M.
Uh-huh.
I thought it was N.
No, I thought it was n. Well, let's check.
Oh, okay. Adjusted pi is it? Okay.
Yeah, pi is m as in Mansfield. Okay. So sphere,
Is that a sports team?
I don't know. Name.
The nice thing about spheres, you just drag it till there's no more numbers.
Yeah.
Makes it easier.
And then what do we say? P is the pi value?
The predicted value,
Mhm.
don't remember, honestly.
I think so. We'll do it and then we'll check it. Of
Always gotta double check.
course. Here we go. We're lined up. Click OK. And this doesn't need to be changed, I think. So let's just click OK. And let's check.
Yeah.
Pi by shape.
Mhm.
Okay. And there are two different curves. Let me just check the scale to make sure that we're capturing everything. I can reset and I can reset here. Okay, that looks good. All right, so now we start to tell a story. So with the spheres, it's always gonna be, for any given value of pi, you're always more likely to say yes than no for a sphere.
Okay.
Which makes sense, right? Because it's curved,
It looks,
easier to grasp.
yeah,
Now, this includes the action trials too, so we kind of made a mistake. This
Yeah.
is just for example.
or,
Are we gonna take out the action trials?
right, when doing the SPSS, analysis, how would you take out the action trials?
Sort by perception action, because we do have that column, yeah? And then just delete those action trials. See this one.
Right, but the SPSS stuff, like, takes the action into account when you need to take the action out whenever you're doing the logistic regression in SPSS.
We're not gonna use it as a variable. We're just gonna exclude those trials.
Right. And what I'm asking is, when you're saying exclude them, are you saying before you run the logistic regression in SPSS? Okay, I thought
Yeah,
you were saying before you
before.
started doing the charting stuff here.
No,
Okay.
no, that's not gonna help, because those predicted values
Yeah,
have action and perception
Mixed,
imbued in them.
and you just want the perception.
We just want the perception,
Yes.
or we may wanna run separate logistic regressions just for perception
And just for action.
just for action.
Yeah.
But now it's all together. All right, but this is what it suggests now. And we did get a difference between the shapes and the logistic regression coefficients. Significant difference. I remember. So that factor was different. So these two curves are actually significantly different from one another,
Mhm.
is what that means.
Okay.
Okay. Okay. So now we can do the same thing for the pi adjusted and see what we get. I can create another plots.
But the pi adjusted will be by tool instead of by shape.
Yes. But we could do this one by tool as well, if we wanted to. And this will be pi adjusted. So not diameter anymore,
But curvature.
curvature. Okay. So now, let's see. First, I just want to freeze the top row so that I know
Yeah, we don't have to keep scrolling back up.
freeze top row. Okay. And now we want to use,
Sort by tool.
yes, we're gonna sort by tool, but we're gonna use pi by tool. This the last column,
Yes.
basically. And we have to sort by tool. Okay. All right, grabber is the first one. And now,
Uh-oh,
see, it messed it up because if I resort, then the plots get messed up. We cannot really plot it in the same sheet, everything. So don't worry about the other one.
Okay.
I mean, it's still the same values, but they belong to different shapes here. It's okay,
Okay.
but now we're focused on that one, so let's try to plot this. So select data,
So instead
and
of,
we're gonna change the name even.
yeah, so instead of
So
sphere and cube, we want hand and grabber.
this is gonna be grabber. And then we're gonna do the, are we doing the pi adjusted? Yes, pi adjusted.
Pi adjusted.
So I wanna see what I'm actually gonna take. Where's the tool? There. Okay, I just wanna see where I am so that I know how far to go down. But this is hand. So I wanna start at the top. Go,
Wait, I thought the X values were the adjusted pi and the Y values were the projected.
oh yeah, you're right, sorry. You're right. So adjusted pi, well, we're in the top, yes, we are. Adjusted pi. Keep going until we reach the end of grabbers. And see, when you add more subjects, this is just gonna be longer.
Right.
So right there, tab, and now the last column. Oops, no, I'm just gonna start with that. I think I'm at the right row. 288,
Yes, I think so.
yes.
Yeah.
And now edits, this is gonna be the hands.
That's pi.
Oh, sorry. Yeah, we were using the other plot. Okay. Tab. And now we're going to the last column. I selected the right one, yes?
Yeah, you did.
I can also sort of check this by looking at the numbers.
You're making sure that matches.
290, 290, 5 is 77, 577. So we're good. Okay, click OK. And OK. All right, let's see the plots. And here's how it looks like.
There's
Why
only
are the labels? Yeah, but it's, I don't know why. Grabber versus hand. Let's just,
Is it because it was still sorted by shape?
but I thought we didn't sort by shape.
Well, because it was sorted by shape in the previous one, now that it's sorted by grabber, like all of the cube trials are still like grouped together. So I think you would have to sort by. Like, I don't know if that matters, if all the cube trials are grouped together.
Let me see, because it does have the two curves. See the blue and the orange curve. So maybe they're on top of each other. Let me see if I can check that. Select data, grabber. I'm just gonna see what we selected. So edit. It selects. Goes to 289. Oops. Yeah. And then it goes to 289. So everything is lined up. That, and then hand. It's the N 290, which is where we're supposed to start, 577. And then 290, 577. Okay. And okay. I mean, they're there. They're just on top of each other. And one color is going to be on top of the other color. So it just happens to be that the hand color is on top of the grabber color.
If you scroll up to the other graph.
But that's all scrambled up.
Right, because that's still the steering cube.
Yeah.
Okay.
And it is a different function because we selected from different predicted probabilities. There's still a factor of tool because I remember tool was significant. So it's two curves still. But I think we made a mistake in including action trials, which is gonna influence all of
If
this.
it's showing two curves, would the points not also be distinct?
Well, I don't know.
Like you
They-
could see
they-
the two different like
we could-
lines.
We could look at the predicted probabilities and compare them basically, but let me think.
Like I just feel like the blue one should show up
Mm-hmm.
somehow.
Because for a given pi value, that is associated usually with a given, I guess with a given object, yeah, for a given tool.
Scroll up again, please. So I wonder. Would the scale of it, like impact, like for example, when we're talking about, even with the adjusted pi ratio, when we're talking about the adjusted pi ratio for hand, that's going to be between 0 and 1. But when we're talking about the adjusted pi ratio for the grabber tool, it's going to be like over 1. Because there are, the width of the grabber is only 12 centimeters and our biggest object is
Yeah.
15 and a half.
Mhm.
Which means that all of those numbers towards the end there that are well over 1 should all be blue, because those would only be grabber trials.
I think something is not right.
Yeah.
Um. I think we have to check the computations. Let's stop the recording because I think we're at the point where